when studying models, okay, it can be helpful to classify them in or identify. So helpful to identify some broad categories. And we're going to look at 4 categories. There are 2 groups of 2, really. And it can be helpful also to look at organizational structure. So, let's consider organizational structure of an animal, say. Then as you look at this, we can kind of look at the hierarchy. Let's see, hierarchy. Good question. Hierarchy. Okay. There we go. Hierarchy of an animal group, something along those lines. So at the high end, you have something like maybe a herd or a flock or something along those lines. And down at the low end, well, we're all made up of molecules. And then we've got stuff in between. So, you've got the herd, then maybe the individual. And then the individual, we're made up of systems and organs and stuff like that. So we'll just say, organs. And then those organs are made up of tissues or cells. So, you could even go like tissues, and then cells, and then down to molecules. And of course, you could even, you could come up with things to probably even fill in here. But that's the idea, right? Is in this hierarchy of some organizational structure that that you want to look at. So this could be, you could look at businesses and and all that, and but it suffices here just to say, okay, yeah. So at the low end, the very, very basic end, we're all made of molecules. But when all those molecules get put together in all these different ways and so forth, we can end up with a herd of animals. Okay, so that kind of brings us to our first pair of classifications. And, whoops. Let's go back. I don't want to install that now. I'll have to try to do that at some point, figure out how. Okay, but back to our stuff here. And so if we talk about a model, which uses a large amount of theoretical information, Okay, now that could well, let's see, a large amount of theoretical information generally describe, I guess, can we get up to here? There we go. Generally describing what happens at one level, you know, so one level in this hierarchy back here, by considering processes, we'll say processes at a lower level, okay, a model which does this, you know, you're kind of using theoretical information, generally trying to describe at one level by considering processes at a lower level, is called mechanistic. Okay, we're looking at the mechanics of the situation. So for instance, you know, and it doesn't have to be really deep, you know, you may try to figure out what's happening with a herd or a school of fish or, you know, a flock of birds or something like that by looking at theoretical understandings of individuals and their needs, and then their relationship with each other as individuals, and then that can possibly produce a model about the herd or the flock or the school. Okay, so that's a mechanistic type of model. And then empirical models, so sort of the opposite. So this is our first pair. Empirical, let's see, is that an I or an E? It's an I, yeah. So empirical, because it sounds like an E, right? So it's an I. Empirical models don't tend to account for what am I trying to say here? Don't really account for, I guess, the mechanism. Mechanism. So if it's not accounting for the mechanism, make it hard to be mechanistic, right? Empirical models don't tend to account for the mechanism of the process. Okay. So we've got empirical versus mechanistic, or mechanistic versus empirical. But then also, so a second pair are, or is, a pair is deterministic and stochastic. So deterministic is not any randomness or chance to it. No randomness. Or chance. And stochastic simply means there's random processes at work. Okay, and so you could, in these broad strokes, we can have sort of 4 different broad classifications of models. We could have empirical and deterministic. We could have empirical and stochastic. And then we could have mechanistic and deterministic. Mechanistic and deterministic, or stochastic and deterministic and mechanistic. Now some examples, might be predicting growth from a regression line. So the regression line, typically, I have no idea what's really going on. I just have some data, and I'm trying to get an idea of some formula to represent that data. Deterministic and mechanistic, that might be something like, planetary motion, where we have the differential equations that we say govern that planetary motion, and then we can integrate those differential equations and play one, say, planet off another, or put a star in there or something like that. But yeah, a lot of times, a lot of these models do use differential equations. And we won't use so much of those, the differential equations. We will see them a little bit, but we won't use the usual solution techniques. And this is because we have 2 other courses in our program that work a lot with differential equations, so we won't rehash them here. Now, stochastic and empirical, these tend to be statistical tests, like analysis of variance, or ANOVA. And they're, things are random, but we aren't really, again, trying to come up with what's going on, or how are things made different. We're just trying to ask, are there differences? And then finally, if you look at mechanistic and stochastic, a lot of genetics, in particular of, say, small populations. There, we believe we have probability rules that govern how the genetics work, and so those are the underlying theory that goes into our mechanistic model. Okay, so there are our two pairs of classifications, kind of making four classifications of models. And, you know, that way it's just good to have some vocabulary. You know, if we're, oh, look at that. You all didn't yell at me when I put an E there. See, empirical. Sorry about that. But you probably laughed or something. But yeah, you know, it's not extremely important that, you know, we're spending all our time identifying whether something's empirical or deterministic or mechanistic or stochastic or what. But it just helps to discuss a model, you know, if you've kind of got this basic understanding of classification here. Okay, so there is our little introductory video on classification.